Good morning friends, welcome to fluid mechanics classes. Today we will solve problems on Bernoulli's equation. So before going to problems, I will just recall the definitions and formula in this equation. Basically Bernoulli's equation is nothing but it gives us relation between pressure, velocity and elevation. Okay, so Bernoulli's equation, it is valid for steady flow, incompressible flow, and where the net friction forces are negligible. And very important assumption that we should remember in deriving Bernoulli's equation is viscous effects. Okay, viscous effects are negligibly small as compared to inertial, gravitational and pressure effects. Okay, so Bernoulli's equation is valid in inviscid flow. So where there is viscous force is dominating, there the Bernoulli's equation is not valid. For example, if this is an object and there is some fluid flowing over this object near the surface of the object, and in this region where the viscous effects are more, here we cannot apply the Bernoulli's equation, whereas we can apply the Bernoulli's equation in this region away from the body. Here the fluid is, we assume it is inviscid flow, means though the viscous force exists but it is very small. Next, so this is the formula Bernoulli's equation, that is P by rho plus V square by 2 plus Gz, where is equal to constant, where P by rho is flow energy per unit mass. This is very important. Okay, this is flow energy per unit mass, and this is kinetic energy per unit mass, and this term is potential energy per unit mass. Okay, so what you can say, in other words, the definition you can say it as the sum of the kinetic energy, potential and flow energies of a fluid particle is constant along a streamline during the steady flow when compressibility and frictional effects are negligible. Means whatever I discussed till now, everything is put in a simple words. Okay, so basically what it is nothing but the conservation of energy. Okay, kinetic energy, potential energy, flow energy. Okay, though they may interchange in a flow, but the sum of all this energy remains constant. Okay, they can convert from one form of energy to another form. Okay, when the fluid is flowing, okay, kinetic energy, potential energy, or to the flow energy, but the sum of all this energy remains constant. Okay, there is one more equation that you need to remember, that is if I take here g, if I divide this throughout the equation by g, then we get this equation. Okay, so this is nothing but P by rho g plus V square by 2g plus z. Okay, so what is the difference between the previous equation and this? Okay, it is pressure energy per unit weight, that you have to remember. Okay, so this term we call it as pressure head. Okay, so V square by 2g, this term we call it as velocity head, and this term we call it as potential head. Okay, so it is nothing but pressure energy per unit weight, and this is nothing but kinetic energy per unit weight, and this is potential energy per unit weight. Okay, so now let's look at the unit of this. So what is unit of height? Unit of height is nothing but meters. Okay, okay, so let me tell you another way. Okay, so what is the expression for potential energy? It is nothing but mgh. In this term, instead of h we write it as g. Okay, so now potential energy per unit weight. So what is a formula for weight? Weight is nothing but m into g. So mg get cancels. What remains is z. For example, if you take this, what is the expression for kinetic energy? It is half mv square. Okay, per unit weight means weight formula is mg. So get cancels. What remains is v square by 2g. Okay, so that's why we call it as kinetic energy per unit weight, velocity head. Okay, and even similarly, if you do, we get pressure energy per unit weight. Okay, so this term we call it as head. Okay, very important, that you should remember. Okay, so now we'll go to the problems. Okay, so first let me take up application oriented problem. Okay, let's go to this example. A large tank open to the atmosphere is filled with water to a height of 5 meters. What it means is, there is a tank. Okay, this tank is filled with water and the height of water is 5 meters. Okay, from the outlet tap, means at the bottom there is a tap. Okay, a tap near the bottom of the tank is now opened and water flows out from the smooth and rounded outlet. Determine the maximum water velocity at the outlet. Okay, so what this problem says is, there is a tank and bottom of the tank there is a tap, and here in the tank there is a water to a height of 5 meters. Okay, so what we need to find, when I open this tap, then what is the maximum velocity of water. Okay, so now, how to assume that this is the problem on Bernoulli's equation. The first thing is, in this problem there are no devices like pump, turbine, or any friction, any components wherein the large frictional losses are involved. Okay, if such kind of devices are not involved in a problem, then this problem is on, you should assume that this problem is on Bernoulli's equation. Okay, so once you decide the problem is on Bernoulli's equation, then immediately what you need to do, you write the formula of Bernoulli's equation. So before that I need to identify points. So surface of the water, I'll mark it as 0.1, okay, which is exposed to atmosphere, and just at the outlet of this tap I'll mark it as 2. Okay, now let me write the Bernoulli's equation. Okay, so it is P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus P2 square by 2g plus Z2. Okay, so now we need to identify the terms. Okay, so let us consider here the surface of water exposed to atmosphere. So here what is the pressure? I'll write it as P1. So P1 is nothing but atmospheric pressure, since it is exposed to atmosphere, P1. And if I take this bottom as the reference, okay, reference point, then this height, okay, then it becomes Z1. So what is Z1? Z1 is 5 meters. Okay, then if I take this, even here when you open the tap, water once it comes out, it is in contact with the atmosphere, so I'll call it a P2 is nothing but atmospheric pressure given here. And what is the Z2? Z2 is nothing but 0, because this we have taken it as reference. Okay, so now, so I got P1, I got P2, I got Z1, I got Z2, and I need V1. We need to find what is v2. We need to find v2 here. Okay, so since in the beginning, so once I open the water tap, water flows out. So v1 is much smaller than v2. So what I can say is we can neglect v1. Since it is very small, very small, we can neglect v1. Okay, so now what happens, I will write once again the equation. P1 by rho g plus v1 square by 2g plus z1 is equal to p2 by rho g plus v2 square by 2g plus z2. Okay, so P1 is nothing but atmospheric pressure here, P2 is nothing but atmospheric pressure. So P1 P2 get cancels, and V1 is very small, so V1 also get cancels. Okay, so now since Z2 is equal to 0, Z2 also get cancels. So what remains is Z1 is equal to V2 square by 2g. Okay, V2 square is nothing but 2gz. V2 is nothing but square root of 2gz. So this is the expression. So this equation we call it as, in general, okay, Torricelli equation. This equation is, we call it as Torricelli equation. Okay, so now let us substitute Z1. Okay, Z1 it is given as how much, 5 meters. So V2 is equal to 2. What is the value of G? 9.81 into 5. So what is the expression you get? Answer is almost equal to 9.9 meters per second. So this is the maximum velocity that we can get. Okay, understood this problem? Okay, so this is very simple problem that I have taken. Okay, otherwise there are a lot of problems. I'll take up one more example. Okay, very important. Okay, let's go to question number 2. The water is flowing through a pipe having diameter 30 centimeter and 20 centimeter at section 1 and section 2 respectively. Okay, so there is a pipe. Okay, the diameter of pipe is, on one side it is 30 centimeter and on the other side it is 20 centimeter. Okay, next, the rate of flow through the pipe is 40 liters per second. Means he has given us the flow rate Q is equal to 40 liters per second. Section 1 is 8 meters above the datum and section 2 is 6 meters above the datum. Okay, so means section 1, I'll show you in sketch. Okay, let me read the problem completely. If pressure at section 1 is 40 newtons per centimeter square, find the intensity of pressure at section 2. Okay, so first let me convert this problem into sketch. Okay, okay, so there is a pipe, okay, whose diameter at the inlet. Okay, if let me consider this as section 1, this as section 2, then d1 is how much, 30 centimeter and d2 is 20 centimeter. Okay, so now, so water is flowing through this pipe and it is coming out at section 2. Okay, the height of section 1 from a reference, okay, we call it a datum. This height is how much, section 1 is 8 meters. Okay, so this height is 8 meters. Okay, and section 2 is 6 meters. So this height is 6 meters from the reference line. Okay, and this is the sketch. Okay, so first let us write what is given. So I will write it as section 1, okay, and section 2. Okay, so what is given? Water is flowing through a pipe having diameter 30 centimeter. Okay, so d1 is 30 centimeter. So 30 centimeter, you have to convert everything into meters. So how much it will be? 0.3 meters. And d2 is how much? d2 is 20 centimeter. It is nothing but 0.2 meters. Okay, you have to convert everything in SI units. Okay, and the flow rate through the pipe is 40 liters per second. So he has given us Q is equal to 40 liters per second. So this liters per second, we have to convert this into meter cube per second. So now how to convert? We know that, okay, I'll write it here. We know that 1000 liters is equal to 1 meter cube. Means if I take a box of 1 meter length, 1 meter breadth and 1 meter height, if I go on putting the water, okay, then that box will hold 1000 liter of water. So that is the meaning of this. Okay, so 1000 liter is equal to 1 meter cube. Then 40 liters is equal to how much? Okay, so it will be 40 by 1000 liters per second. Okay, so if you simplify that, then it will come out to be 0.04 meter cube per second. So this get cancelled. So this is the value of cube. Now I have converted 40 liters per second into 0.4 meter cube per second. Okay, so now, so section 1 is 8 meters above the datum. It is nothing but Z1. So Z1 is 8 meters and Z2 is 6 meters above the datum. Okay, next, if the pressure at section 1, so P1, if the pressure at section 1 P1 is how much? 40 newtons per centimeter square. Okay, so now we have to convert this centimeter square into meter square. So how to convert? We know that 100 centimeter is equal to 1 meter. Okay, if I square this, 100 centimeter square is equal to, 1 square is nothing but 1 meter square. Okay, so 1 centimeter square, because here centimeter square, I need to convert that into meter square, is nothing but how much? 10 raised to minus 4 meter square. Okay, so where centimeter is there, you substitute this. So P1 is nothing but how much? 40 newton per 10 raised to minus 4 meter square. So I can write this as P1 is equal to 40 into 10 raised to 4 meter square. Okay, so now I have written everything. Always whenever you are solving problem, you read the problem. Okay, you first write all the given data, whatever is given, and convert everything into SI units. Okay, once you convert, then your 50% of solution is done. Okay, next, it's purely mathematics. You know the formula, substitute and get the answers. Okay, so now let's go to the, so first I will write the Bernoulli's equation. Okay, that is P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2. Okay, so we need to find this. We need to find what is P2. We need to find this. He has asked us to find what is pressure at section 2. Okay, P1 is given. Okay, and Z1 is given. Have they given velocity? So velocity is not given. We need to find this, and they have given the Z2, and we need to find V2. Okay, so P1, Z1, Z2 are given, but V1 and V2 are not given. We need to find V1 and V2, then substitute in this equation. Okay, and get the answer. Okay, so now how to find V1 and V2? Okay, to find that, he has given us the flow rate. Okay, so you know the continuity equation. What is continuity equation? I will just divide this into two parts. Okay, what is continuity equation? Okay, so continuity equation is nothing but Q is equal to A1 V1 is equal to A2 V2, where A1 and A2 are cross section areas. Okay, so now we need to find A1 and A2. Okay, and substitute here. You know already Q. If you find A1, because already they given us the diameter. Okay, diameter is given, D1 and D2 are given. Substitute A1 and A2 and you will get V1 V2. So what is A1? A1 is nothing but pi by 4 D1 square. So pi by 4. What is D1? D1 is 0.3 square. So how much it comes out? Zero point 0.0707 meter square. So let us cross check once. Pi by 4 into 0.3. So 0.07068. So I'll round it off, 0.07 meter square. Okay, now let us find A2. Pi by 4 D2 square. Nothing, pi by 4 into 0.2 square. Okay, so it comes out to be 0.0314 meter square. Okay, so I can find V1. V1 is nothing but Q by A1. What is Q? Q is nothing but 0.04, okay, divided by how much is A1? A1 is 0.0707. Okay, that is cross check. It is 0.5658 meters per second. Similarly, V2 is equal to Q by A2, 0.04. Okay, 0.04 divided by 0.0314. So how much it is? 0.04 divided by 0.0314. 1.2739 meters per second. Okay, so now we know V1, V2. So we got V1, we got V2. Okay, so let us substitute this in this formula and get the answer. Okay, So what is P1? P1 is how much? 40 into 10 raised to 4 Newton per meter square divided by, since it is in the problem he has given it as water, okay, so density of water is how much? 1000, okay, and value of G is 9.81 plus V1 square, V1 is given it as 0.5658 whole square divided by 2 into 9.81 plus Z1 is how much? Z1 is 8 meters. So we need to find P2. We'll keep it as it is, P by 2 into G plus V2 square velocity. V2 is how much? 1.2739 whole square divided by 2 into 9.81 plus Z2 is 6. Okay, now we have to simplify this. Once you simplify this, you will get P2. It's pure mathematics. Okay, so once you substitute, okay, so if you simplify this, you will get it as 40.17 plus, if you simplify this, you will get it as 0.0163 plus 8 P2 by rho G plus, if you simplify this, you will get it as 0.0827 plus 6. Okay, so you add all this, you will get it as 48.7863 P2 by rho G plus you get a 6.0827. okay, so P2 is equal to, you take this on the left hand side, 48.7863 minus 6.0827. okay, so P2 is equal to, you take this on the right hand side, so you will get it as 48.7863 minus 6.0827 into G is 1000 into 9.81. okay, so when you simplify, you will get the value as 41.89 Newton per centimeter square. No, in fact you will get it in Newton per meter square. So since he has given P1 in Newton per centimeter square, we have to convert that into Newton per centimeter square. Okay, otherwise even if you keep it in Newton per meter square also, no problem. Okay, so these are the two problems. Again in the next class we'll take up more examples. Okay, so if you have any doubt, please contact me. Thank you.